So hello and welcome back. So in this video we are again doing another example from Khan Academy, and this is also a very good example. It's related to exponential functions, but the kind of function where the variable has been divided by some number. So it's the index is not a simple index containing just the variable. It is basically a fraction. So let's first understand the problem, and then we will talk about how we can solve it. So basically, a chemical element naturally loses its mass over time. A sample of this element had an initial mass of 320 grams an initial mass of 320 grams when we measured it. So the initial mass was 320 grams. The relationship between the elapsed time t in days, t is in days, and the mass m of t in grams left in the sample is modeled by the following function. So this is basically m of t is the mass of this element in grams left in the sample. The emphasis is on the amount left as a result of the element losing its mass over time. So now the question is, the sample loses 87.5% of its mass every how many days? 87.5%. So what you need to understand here is that first you need to understand what sort of relationship we have between m of t and t. So m of t is 320 times 0.125 raised to the power t divided by 61.4. So what this relationship actually means is that, well, let's say that you have m of t is equal to 320 times this whole thing, and this is basically an exponential function. An exponential function has some variable, for example, let's say t, and you have some m of t, for example. This is the mass left, for example, in grams, and this is t in days. So this m is dependent upon t. Now normally what happens in an exponential function is that you could start with an initial value, for example 0, and in this case it was 320 grams. And this element is losing 87.5% of its mass every whatever days. Now if you want to write a relationship for that, basically means that you are left with, so if you're losing 87.5%, so losing 87.5% means that you're left with what percent? You're left with 12.5%. That basically the same thing. So basically means the same. When you say you're losing 87.5%, is the same thing as saying you're left with 12.5%, because 12.5 plus 87.5 is equal to a 90, 99 and 100. So this is 100%. Now now here what happens is that if I increase my input to 1 here in this function, if I increase my input to 1, normally what happens is that this output is supposed to be multiplied by something. You have seen this in all the other examples, that basically it's a definition of an exponential function, that every time you increase your input by 1, your output is multiplied by some factor. For example, in this case, let's say that every time you increase your input, your output is multiplied by 0.125. So now, if m of t when t was 0, if m of t was 320, now when t is equal to 1 after 1 days, you are left with 320 times 0.125. So when you multiply 320 by 0.125, that means that you are taking 12.5% of 320. That means you have 320 and you're taking 12.5% of 320, and that's basically the meaning of this number, of this whole expression. And that's basically the same thing that we had here. You're losing 87.5%, so that means you're left with 12.5%, and 12.5% is basically 0.125. So you're multiplying 320 by 0.125. Now, this happens when t goes from 0 to 1. But so every time t is incremented by 1, this happens here. And so you are left with 12.5% of whatever you had in the previous point, or in the previous let's say, I don't know, let's call it cycle of t. But here now the problem is that here, in order for this to happen, that's basically the question here. The sample loses 87.5% of its mass every how many days? That's the same thing as asking the sample is left with 12.5% of its mass every how many days? And how can that happen? That can happen if your t goes from 0 to 1, and then whatever you had as the output of the function here will be multiplied by 0.125, and then you are left with 12.5% of your previous mass. But the problem here is that when I increase my t here from 0 to 1, t goes over here. And t here is then multiplied by the function, is multiplied by 61.4. So when t is 0 and then becomes 1, then it's actually not 1, but 1 divided by 61.4. So that basically means that this whole fraction has to become 1, so that then you have, for example, 320 times 0.125 raised to the first power. And then that basically means that you have one complete factor of 0.125 multiplied by 320. And so then that basically means that then this thing has happened. And so then you are left with 12.5% of 320. So how can that happen? It can happen if this fraction becomes 1. And this fraction can only become 1 when t is equal to 61.4. So basically, the sample loses 87.5% of its mass, or the sample is left with 12.5% of its mass every 61.4 days. That's how you solve this kind of problem. You can also solve this problem in another way, but it's, I mean, you could keep multiplying, or you could use this let me see. Basically, this was one way. Another way to solve this problem without analyzing the relationship or the equation is to set I don't know about that. I would need to think about it and find some way to do it, or using a table or whatever. I don't know, but basically this way you can always know what's happening in this equation, and then you can answer such questions. I might try to solve this problem in another way, using I'm kind of thinking that it's possible to solve this problem in another way, but I don't quite see the strategy in my mind, so I might do it later probably. So that's basically this problem, and I'll see you in the next video. Thank you.